Section 2.3, we will introduce Newton's law of cooling. So to start off here with a definition and a formula, and this states that the rate of heat loss of a body is proportional to the difference in temperature between the body and its surrounding environment. So temperature gradient is really important. So the delta T is proportional to K multiplied by the difference in temperature, the gradient. And K is a cooling constant dependent on material properties and conditions. So not critical to know this, just to understand that the temperature gradient is a direct impact on the rate of cooling. Now, in human system, K is impacted by a lot of different variables, so it's not a clear constant. It is impacted by clothing and insulation, so depending on what the individual is wearing, the amount of surface area exposed, the medium by which heat is transferring, so there are slightly different equations if it's conduction versus convection. So again, the medium that's involved, whether it's contact into air, into water, as well as the convection speed. So if you have air flowing, water flowing, a lot of different variables that go into Newton's law of cooling. The implications we have for exercise is looking largely into the temperature gradient. Now, core temperature is high, but we're largely going to be looking at transferring heat out of different portals on the body. So skin temperature is still relatively high, often in the low 30s. So we would say low 90s of Fahrenheit. And if you compare that to environments, unless you're in extremely hot environments, in most, let's say, temperate conditions or moderate conditions, such as room temperature or an air-conditioned environment, there is a large temperature gradient. Now, until you start getting to the very high end of temperature, that's when you see the gradient start to dissipate, and that's when it gets more challenging to cool the body. So again, effectiveness is going to depend on conduction, convection. It is quite nuanced how cooling is best conducted depending on the environment and the medium, and that's what we're going to explore a little bit more. But some practical examples here. Cold water immersion, for example, is super effective at lowering core temperature and dumping heat for a lot of different reasons. It maximizes temperature gradient. You can get a very large gradient, especially if you're in 45, 50 degree water or colder. You have really great thermal conductivity with heat transfer into water as a medium, as well as circulation is able to create a lot. And then you have really large surface area and a really large heat sink. So the total heat capacity of the ice bath. So that's why you see cold water immersion really as the gold standard for rapid and total extreme cooling of core temperature. Athletic applications, understanding Newton's law is really just to understand how effective you can expect cooling to be in different circumstances, and then what variables you can manipulate to try to increase cooling depending on those conditions, and then try to stack different interventions to optimize for K, optimize for the cooling constant, get the maximum effectiveness of heat dissipation, keep your athletes in healthy and optimal thermoregulation range.